Quick question. You have got a list with the 10 items in Grasshopper. What's the index of the very first item? If you said 1, that's the single most common mistake in all of Grasshopper, and it causes more errors than anything else in the software. The answer is 0. In Grasshopper and in almost every programming language that exists, counting starts at 0. Today, that idea goes from something I heard to something that permanently wired into how you think. This is day 8. We are opening phase 2, data understanding. And today we go deep on list. No shortcuts, no hand waving. By end of this video, you will understand Grasshopper's data system better than most people who have been using the software for years. Here's something that will change how you see every wire on your canvas. Every piece of data in Grasshopper lives inside a list. Even a single number, a single point is technically a list containing exactly one item. That's not trivia. It's the reason certain things behave the way they do. And it's the first thing you need to understand before anything else in this phase makes sense. Think of a list as a row of numbered lockers. Every locker has a number on the door, and that number is the item's index. Locker number 0 holds the first item. Locker number 1 holds the second. If you have 10 items, they fill lockers 0 through 9. There is no locker 10 because there are only 10 lockers in total and counting started at 0. The formula we need is x percentage 2 equals 0. Let's break that apart completely piece by piece because I don't want a single symbol left unexplained. Open a fresh Grasshopper canvas. Double-click the canvas to open the search bar, type series and place a series component. Set series input, start 0, step 1, count 10. Double-click canvas, type panel, place a panel component. Connect series output to panel input. Look at what the panel shows you. At the top, 0, 0. That's a list branch label. We are covering branches properly tomorrow in the data trees video. For today, just know that everything below that label is one single list. Below it, 10 lines, each starting with a number in square brackets, 0, 1, 2, all the way to 9. That bracketed number is the index. 10 items, indices 0 through 9, never 1 through 10. Double-click canvas, type list length. Place the list length component. Connect the series output yes to list length input L. Add a panel to the list length output. List length just counts. It reads 10. But here's the trap. The count is 10, while the last index is 9, because index 0 already used up the first slot. Count minus 1 always gives you the final index. That single fact is what most Grasshopper index error come down to. Double-click canvas, type list item, place a list item component. It has 3 inputs, L, the list, I, the index, W, wrap, a boolean. Connect series output yes to list item input L. Double-click canvas, type number slider, place a slider. Right-click the slider, set it to integer type, minimum 0, maximum 9, current value 0. Connect the index slider, list item input. Add a panel to the list item output, rename it to selected items. The panel reads 0, the first item. Drag it to 4, it reads 4. Drag it all the way to 9, it reads 9, the last item in a 10 item list. Drag the slider to 10. Watch what happens at index 10. The component turns orange and throws a runtime error, something like index out of range. There's no locker number 10, the list only goes up to index 9. Right-click the W input of the list item. Choose Set Boolean, click True. Drag the index slider back to 10, then 11, then 12. Now with wrap turned down, index 10 loops back around to item 0. Index 11 wraps to item 1. This is genuinely useful for anything cyclical, repeating patterns, looping through a set of materials, anything where you want the count to keep going past the end without erroring out. Right-click the index slider, reset the maximum back to 9, turn wrap back to false. Double-click canvas, type reverse list, place it. Connect the series output yes to the reverse list input L. Add a panel to the output. Reverse list does exactly what it says. Our list was 0 through 9 in order. After reverse list, the panel reads 9, 8, 7 all the way to 0. What was last is now first. Before we can filter a list by even or odd, we need one more idea, the Boolean value. A Boolean is just a value that either is true or false, nothing in between. Grasshopper's component that filter data, Cull Pattern, Dispatch, all run on list of true or false value that you provide. So the real question becomes, how do you generate a true or false value for every number in our list, where true means this number is even and false means this number is odd? That's exactly what an expression component does. It lets you write a small formula and it runs that formula on every item in the list. one at a time, producing one output for each input. The formula we need is x percentage 2 equals 0. Let's break that apart completely, piece by piece, because I don't want a single symbol left unexplained. X is just a name, a placeholder, for whatever number is currently being tested. When we connect our list into the expression components x input, Grasshopper runs that formula once for every item, substituting the item's value in for x each time. Percentage symbol is a modulo operator. It doesn't mean percent here, it means divide and give me only the remainder. 10 percentage 2 means divide 10 by 2 and tells me what's left over. 10 divided by 2 is 5 with nothing left over. So 10 percentage 2 equals 0. But 7 percentage 2 means divide 7 by 2, that's 3 with 1 left over. So 7 percentage 2 equals 1. Every even number when divided by 2 has nothing left over. The remainder is always 0. Every odd number always has a remainder of 1. That's the entire mathematical definition of even, a remainder of 0 when divided by 2. So the full formula x percentage 2 equals 0 reads as, take this number, divide it by 2 and ask whether the remainder equals 0. For every even number, the answer is true. For every odd number, the answer is false. Double-click canvas, type expression, place it. Double-click the expression component itself to open the formula editor. Type exactly x percentage 2 equals 0. Click OK. Connect the original 10 item series output yes to expression input x. Add a panel to the expression output. Look at this panel, 10 values, true false, true false. That's our even odd pattern, generated directly from the numbers themselves, not typed in by hand, calculated automatically. Every even valued item produced true. Every odd valued item produced false. Double-click canvas, type Cull pattern, place it. Connect the original series output yes to Cull pattern input L. Connect the expression output to Cull pattern input P. Add a panel to Cull pattern output. Here's exactly what Cull pattern does. For every item in the L input, it checks the matching position in the P input. Where P is true, the item is kept. Where P is false, the item is removed, culled from the list. Our P input was generated by is this number even? So the surviving list is 0, 2, 4, 6, 8. Every even number kept, every odd number culled out. Double-click canvas, type dispatch, place it. Connect the original series output yes to dispatch input L. Connect the expression output to dispatch input P. Add two panels, one to output A, one to output B. Dispatch does something slightly different and is often more useful. Instead of throwing away the false items, it splits the list into two separate lists. Everything marked true goes to output A. Everything marked false goes to output B. Nothing is deleted, the list is just divided into two. Panel A reads 0, 2, 4, 6, 8, the even numbers. Panel B reads 1, 3, 5, 7, 9, the odd numbers. Same source list, same true or false pattern, two clean separated results. Double-click canvas, type Cull Nth, place it. Connect the original series output yes to Cull Nth input L. Set the N input to 2. Add a panel to the output. Cull Nth removes the item out of every N, counting positions starting from index 0. With N set to 2, it removes every second item starting the count at the very first one. Read the output carefully. 0, 2, 4, 6, 8. Items at index 1, 3, 5, 7 and 9 were removed. The item at every second position was culled. It happened to look identical to our even or odd filter here, purely because our list values match their own index numbers. Don't rely on that shortcut. Cull Nth removes by position. Cull pattern and dispatch filter by whatever true or false pattern you feed them. Where all these gets genuinely useful. A row of 40 facade panels and you want to knock out every third one for the recessed detail, that's Cull Nth with N set to 3. Instantly, no math required. Your day 8 challenge. Build a 10 item list of points spaced along the x-axis. Series into the construct point component. X driven by the series, Y and Z left at 0. Use an expression component to generate a true or false is even pattern based on the point index. Feed that pattern into a dispatch component, splitting your 10 points into the even index group and an odd index group. Place a circle at every even index point. Place a rectangle at every odd index point. The result, altering circles and rectangles along a line. A genuine facade alteration pattern, built entirely from list logic. If you've done it right, it should look something like this. Here's everything day 8 covered. Every value in Grasshopper lives inside a list. Indexing starts at 0 always. List length counts item. List item retries 1 by index. Reverse list flips order. Sortlist orders numbers ascending. The expression component builds true or false pattern from real math, and those patterns drives Cull Pattern and Dispatch, the two core filtering tools. Cull Nth removes items by position, not values. Tomorrow is genuinely the most important video in this entire 60-day course. Data trees. What are they? How to read them, and why understanding them eliminates roughly 80% of every error you ever see in Grasshopper. If you only watch one more video in this series, make it day 9. Subscribe. See you there.